Namaste, good morning everybody. I am Lakkanna EN, Assistant Professor, SBSS Government First Grade College, Gajendragad. Karnataka State Higher Education Academy, Dharwad has arranged induction training for assistant professors in physics, mathematics and chemistry in two phases, 10 days online mode phase 1 and 11 days offline mode phase 2. As a part of induction training, I have allotted two topics for presentation. In first round presentation, my topic is polar equation of a conic, and second topic is relation between gamma and beta functions. And after the first phase of online training, I am going to make this video in topic 1, polar equation of conic. I thank Director Shivaprasad sir and coordinator Arundhati madam for arranging online training, which they give a lot of information with the good resource persons. Based on the knowledge gained and my own knowledge, I am making this video and I am learning a lot of things in making online videos, and thank you very much. In this video lecture, we are going to discuss polar equation of conic. In these figures, we observe that a right circular double cone is being intersected by a plane. Intersection of the plane and a right circular double cone gives curves like parabola, ellipse, circle, hyperbola if the plane doesn't pass through the vertex of the cone. And if the plane passes through the vertex of the cone, the curves may be a single point or a straight line or a pair of intersecting lines. These curves are called conic sections or simply conics. Now, definition of a conic. A conic section or simply a conic is the curve obtained as the intersection of a plane called the cutting plane with the surface of a double cone. It is usually assumed that the cone is a right circular cone for the purpose of easy description, but this is not required. Consider the case where the cutting plane passes through the vertex of the cone as shown in these figures. Clearly, in these cases, intersection of the plane and the cone gives a single point or a straight line or a pair of intersecting lines. These three conics are called degenerate conics. Definition of degenerate conic. A degenerate conic is the curve obtained as the intersection of a plane with the surface of a double cone passing through the vertex of the cone. It is a point, a line, or a pair of intersecting lines. Consider the other case where the cutting plane does not pass through the vertex of the cone. In these cases, the conics obtained are called non-degenerate conics. As you see in these figures, ellipse, circle, hyperbola, parabola are non-degenerate conics. Definition of non-degenerate conic. A non-degenerate conic is the curve obtained as the intersection of a plane with the surface of a double cone that do not pass through the vertex of the cone. It is an ellipse, a parabola, a hyperbola, or a circle. Other definitions of a conic. A conic is a quadratic equation in two variables. Taking x and y as two variables, the general form is ax square plus bxy plus cy square plus dx plus ey plus f equals 0 with all coefficients real numbers and a, b, c not all 0. A conic may be defined in another way also using the focus and the directrix. A conic is the locus of a point in a plane such that the ratio of its distance from a fixed point in the plane to its distance from a fixed line in the plane is constant. The fixed point is called the focus. The fixed line is called the directrix. The constant ratio is called the eccentricity, denoted by E. Let us look at focus directrix definition of conic in detail, as this definition of conic is used to derive equation of the conic. Consider a fixed point S in the plane and consider a fixed line D in the plane. S is called the focus, D is called a directrix. Take a point P1 in the plane. Distance of P1 from the focus is P1S. Draw a line P1Q1 perpendicular to D. Distance of P1 from D is P1Q1. Ratio of distances of P1 from the focus and the directrix P1S divided by P1Q1. Say E a constant. Take another point in the same plane P2. Distance of P2 from the focus P2S and draw a line perpendicular to D from the P2, P2Q2. Ratio of these two distances P2S by P2Q2 equals E. Then these 2 points lie on the same conic. Collection of all such points which have the same ratio as E is called a conic. Then conic is looking like this curve. Thus, conic is set of all points in the plane which bear constant ratio of distances from the focus to the directrices. Shape of the conic is determined by the eccentricity E. If E equals 1, the conic is a parabola. If E is less than 1, the conic is an ellipse. If E is greater than 1, the conic is a hyperbola. If E equals 0, the conic is a circle. Equation of conic in Cartesian coordinates. Parabola. Y square equals 4ax, where a is greater than 0, is equation of the parabola with focus at a, 0 and directrix x equals minus a. Ellipse. X square by a square plus y square by b square equals 1, where a is greater than b, is the equation of ellipse with foci at plus or minus ae, 0 and x equals plus or minus a by e as directrices. Hyperbola. X square by a square minus y square by b square equals 1 is the equation of hyperbola with foci at plus or minus ae, 0 and directrices x equals plus or minus a by e. Now we shall see the conics in polar coordinate system. First, recall polar coordinates. It is a two-dimensional coordinate system in which each point in a plane is determined by a distance from a reference point and an angle from a reference direction. This is polar coordinate system. The reference point is called the pole. The ray from the pole in the reference direction is called the polar axis or the initial line. The distance is called the radial coordinate or radius, denoted as r. The angle is called the angular coordinate or vectorial angle, denoted as theta. Thus, any point in the plane P has two coordinates r and theta. Angle is taken in the anticlockwise direction. Now we shall derive polar equation of the conic. For simplicity, we shall take pole as the focus and directrix perpendicular to the initial line. Consider the polar coordinate system. S is the pole and we shall take that as the focus of our conic, and SA is initial line. Take the directrix perpendicular to this initial line at a distance d from the pole. Now this is conic. Take any point P r comma theta on the conic. Then PS equals radius r and angle PSA is theta. Draw PM perpendicular to the initial line, PN perpendicular to the directrix. In the right angle triangle PMS, one can easily see that SM equals r cos theta. Now, using the definition of conic, ratio of PS and PN is a constant and we shall call that constant E. Therefore, PS by PN equals E, which implies PS equals EPN, which implies PS equals EMA. In the diagram, PN equals MA, which implies PS equals E times SA minus SM. Substituting the values of PS, SA and SM, R equals E times D minus R cos theta, which implies R equals ED minus R E cos theta. Rearranging the terms and taking the common factor, which implies R into 1 plus E cos theta equals ED. Therefore, R equals ED by 1 plus E cos theta is the polar equation of the conic. We can also write the polar equation in terms of semilatus rectum. Latus rectum is a chord of the conic that passes through the focus. Take this is the semilatus rectum. SL is the semilatus rectum and taking its length as small l. Draw LK perpendicular to the directrix. Then clearly LK is D. So by definition, SL by LK is equal to E. So in terms of semilatus rectum, we have SL by LK equals E, which implies SL equals E times LK, which implies L equals ED. Therefore, above equation becomes R equals L by 1 plus E cos theta, or L by R equals 1 plus E cos theta. E is polar equation of the conic, where L is semi-latus rectum of the conic. Note: in the above derivation, we taken directrix is perpendicular to the initial line. If the directrix is inclined at an angle theta naught with the initial line, then equation of the conic is R equals ED by 1 plus E cos theta minus theta naught. Second one, depending on the position of directrix with respect to initial line, equation of conic is R equals ED by 1 plus or minus E cos theta if the directrix is x equals plus or minus d. R equals ED by 1 plus or minus E sin theta if the directrix is y equals plus or minus d. Let us look at some examples. Example 1. Identify the conic R equals 6 by 2 minus cos theta. Solution. Comparing with standard form R equals ED by 1 minus E cos theta, we have R equals 6 by 2 minus cos theta. Taking 2 as common factor in the numerator and denominator and cancelling, R equals 3 by 1 minus 1 by 2 cos theta. Comparing with the above standard equation, we see that E equals 1 by 2, which is less than 1. Therefore, given conic is an ellipse. Example 2. Identify the conic R equals 12 by 4 plus 5 cos theta. Solution. Comparing with standard form R equals ED by 1 plus E cos theta, we have R equals 12 by 4 plus 5 cos theta. Taking 4 as the common factor in the numerator and denominator and cancelling, we get R equals 3 by 1 plus 5 by 4 cos theta, which implies E equals 5 by 4, which is greater than 1. Therefore, given conic is a hyperbola. Example 3. Find the polar equation of parabola in terms of semilatus rectum. Solution. Equation of conic in polar form is L by R equals 1 plus E cos theta, where L is semilatus rectum. For parabola, we have E equals 1, which implies L by R equals 1 plus cos theta, which implies L by R equals 2 cos square theta by 2 using half angle formula, which implies R equals L by 2 secant square theta by 2 after rearranging. This is the equation of the parabola in terms of semilatus rectum. Now let us look at applications. A polar form of the equation of a conic is often used in dynamics. For instance, determining the orbits of objects revolving about the sun is expressed in terms of polar equations. References: online sources, Wikipedia, University of Texas at Austin website. Textbooks: a textbook of mathematics for BSc second semester as for the KUD syllabus by N. Ramesh, a textbook of mathematics BSc second semester as per the KUD syllabus by Jyoti Akki. Thank you very much for watching this video. I thank Director, Karnataka State Higher Education Academy, Dharwad, Dr. Shiv Prasad sir, and Coordinator, Dr. Arundhati Kulkarni madam, for providing us this opportunity. And I also thank all the resource persons which gave us knowledge in making this kind of videos. Thank you. Namaste. Take care.